one of three binary tree zigzag level order traversal. So in this question we have to return the values of nodes for each level. So we are returning 3, and then the next one we are returning 20 and 9 from right to left, and then the next level we are returning 15 and 7, which is left to right. So it's a zigzag pattern. So this question is very similar to 102, because 102 was basically showing all the nodes from left to right. So what we can do is we can just copy the answer and then make one small change in our question. So what we're going to do here is we're going to introduce a variable called int level, and then we're going to set it to 0. And we've seen that for every odd level we had to reverse the nodes. So instead of adding the values here, we can do if level modulus 2 is equal to 0. We add them directly, else we have to reverse the sub answer. Collections.reverse sub ends, and then return add that reversed to our answer, and then we do level plus plus. Let's run the test. Okay, let's submit. All right, let's quickly have a look at the faster method. Okay, so this is exactly same as what we have, and it must be the internet speed. Let's have a look at the other answer. Okay, so this one is different. It's not using collections.reverse, it's using this toggle, and based on this toggle we sometimes add node to the last and sometimes add node to the first. But the question is, why is this same speed as our code? Our code uses collections.reverse, which is additional computation, and has speed complexity of O of n, time complexity of O of n. Well, the reason is we can see that for every node we have to go through this conditions. And in CPU we have something called branch predictor, which tries to guess which way a branch will go before this is known definitely. So basically CPU runs the process, executes the instructions even before it is run, and so it's based on CPU speculation. So CPU assume that it is if and doesn't run else. And then when it comes to the actual branch, if it finds out that its speculation was wrong, it needs to do the calculation again. So we end up wasting a couple of CPU cycles, say 10 to 15 CPU cycles, and everything is happening for every node. But if you look at our example, it's not happening at every node, it's happening, the collections reverse is happening at every level. But you might be thinking, okay, let's have a look at the collections reverse method definition. So we do also have this condition here, I is less than mid. So that's a condition. Why don't we get like a branch predictor coming into play? Well, the thing is, so what this method does is we are swapping the two ends of the element until I is less than mid. So until I is less than mid, everything will be true, and then only for the last one, I won't be less than mid, so that will be false. So all of them will be branch predictable friendly. And another thing to note is we are using array list, and arrays are contiguous in memory, which means they're next to each other, so it is cache friendly, hence it's quite quick. So that's why these two different methods are of the similar speed.